We are going to continue on with equations that have two variables. So we're going to look at the distance formula, which is the formula that you see pretty often to calculate distance. So distance is going to be your rate times time, and your rate's just your speed. So we're going to look at an example, and we're going to have a train here that's traveling 40 miles an hour between two cities. So we're going to use a graph, and we're going to show the relationship between the time and the distance traveled. So if we travel for 1 hour, then we know that we're traveling 40 miles an hour. If we travel for 2 hours, add another 40, we're going 80 miles. Okay, so then let's say, well, what if we travel for 4 hours, or what if we travel for 6 hours? We can use what we know about ratio tables too and see, well, this is 1 times 40, that's how we get here, 2 times 40. So if we do 4 times 40, we get 160. 6 times 40, we're going to get 240. Okay, so now we're going to take what we know about ratio tables, what we just did here, and we're going to translate that into an equation. So we're going to take those 1, 2, 4, and 6 hours here. And then we're going to say, well, here's our distance formula, but we have that 40 in there for speed. So I'm going to rewrite this, but instead of time, I'm going to put 1 for 1 hour. So 40 times 1. Here, I'll do the same thing. Instead of t, I'm going to put 2 for 2 hours. Okay. Then you are going to calculate your distance by solving that. So 40 times 1, okay, that's going to be 40. 40 times 2, that one's going to be 80. And then if you set this up right, you should get the same values you have up here. So then the last column is your ordered pair. So time and then distance. So 1, 40 is my first ordered pair. Then 2, 80. Go ahead and fill in the rest of that table. All right, so now we're going to transfer this to the graph. So time, a good rule to remember is that time always goes on the bottom for measuring something over time. And this is being measured in hours. And I'm just going 1 through 6, so I would just count by ones. 0, then 1, 2, 3, 4, 5, 6, and so on. If you're not really going above 10, I would just count by ones there. And then over here on our y-axis, that is our distance. In this case, we're going to measure that in miles. All right. And then for the miles, we have 40, 80, 160. So I would just use that 40. Count by 40s here. So don't make it super difficult on yourself. So start with 0, and this is 40. So here's our 80, 120. 160, 200, 240, this would be 280, so this would be 320. Okay. Then this whole graph is going to represent the speed of a train, or train speed, however you want to word that. And just go ahead and graph your points. So I have 1, 40, 2, 80, and so on. So go ahead and graph your points and then connect your dots there to make your straight line. So if I connect my dots in this one is going to go through 0, 0, because if this train travels for 0 hours, it's going to go 0 miles. It's not going to go anywhere. Okay. So on the back page is where I had you try some of these on your own in class. So let's go ahead and take a look at some of those. So on the first ones, 1 and 2, you're just substituting those numbers in there and saying if they're an ordered pair. So if you haven't already, pause your video and do that so you can unpause and check your work. All right, so number 1 would not be a solution, and number 2 would be a solution. Number 3, here's the equation we have. This represents the amount in your savings account, which is your Y, after you've saved for X amount of weeks. So think about which one of those depends on the other. Does it depend on how much money you have in your savings account? For how many weeks you save, or does the number of weeks you save depend on what's in your account? So which has to come first, the money in your account, or do you have to save first? So that's how you're going to think about it to define which is your independent and dependent variable here. So the amount in your savings account is going to depend on the number of weeks you save. So Y is your dependent and X is your independent. So now for letter B, how much is in your savings account after 8 weeks? So 8 weeks, that's going to represent your X. So if X is 8, you're going to substitute that into that equation, 10X plus 25. So pause your video and substitute that X in there and solve. So you would have $105 in your savings account after 8 weeks. All right, number 4, I'll help you get started on this one. So it's $25 to rent a kayak plus $8 for each hour. Okay, so we're going to write an equation and then we're going to graph it. So think about, you're going to have Y equaling however much money it costs to rent it up front. You're going to pay this no matter what, plus the amount of money it costs per hour. We don't know how many hours. So fill in what's going to go in there. All right, so once you fill this in, $25 plus the $8 per hour. Now I want you to create a table, okay, for the cost and the hours. So pick some easy numbers to work with. If I rent the kayak for 1 hour, how much is it? If I rent it for 2 hours, if I rent it for 3 hours, and so on. So you would substitute this in for X to get your Y. Okay, so I have my table set up. If I rent that for 1 hour, it's going to be $33. For 2 hours, it's $41. For 3 hours, it's $49. So I just counted by ones for hours. I counted by fives for the cost. There's not a super obvious way to do it, so some people might have counted by 8 or 10. So I just went by fives. So your numbers are, your points, your order pairs will be somewhere in between. So I go over to 1, up to 33, so that's going to be just before 35 here. Over to 2, up to 41, and then over to 3, up to 49. All right, and then your line should go through 25 here because it's going to cost you $25 to rent that kayak no matter what.